Okay, greetings, students. So, in the last lecture, we have been discussing about your PV bus problem. So, in that, we have seen up to your bus voltage of V2. Okay, so V2 over here corresponds to your PV bus. So, up to that, we have seen through it. So, after that, your third and fourth bus resembles your PQ bus. So with respect to PQ bus, directly you can just put the value of your real power, reactive power as given in the question. Okay. So after substituting, and over here you have to know the value of V21. Okay, for this parameter. Okay, over here for this parameter, you have to know the value of your V21, and this V21 is found from your previous step. Okay, it is found from your previous step. Okay, similarly, as you progress through your various buses, you have to consider the value of your previous bus. Okay, so here we are considering the for the V3 bus, you are considering the value of your previous bus, that is your V2. And coming to your V4, you have to consider you have to consider the bus V3. Okay. So as they are connected with each other, they are interdependent among them. And okay, so this is the calculation. You can just check along with the thing that you have worked out. Okay, if you have worked out, you can cross check with this value. So here they have given we got the acceleration also the same value because your alpha is 1. Okay, so you'll be getting the same value. So moving on to your V4. So this is your V4. So in your V4, as I said, this value will be depending upon the previous voltage. So here it depends upon the two values of
So,
V2 dash.
can I show the
V-
V3 on voltage, sir? Because its
okay, okay,
answer is differing from it, sir.
okay. Here you can see. Okay, you can just cross check it. I'll be just waiting. I'll be wait. No problem.
Sir, you have done something wrong, sir. In 1.2 plus 4j, it should be multiplied with 1.06, sir. Instead, you multiplied it with 1.6, sir.
1.6, right? So writing, I made some mistake. So you just cross check whether you are getting around this value.
So this is the right answer, sir.
Yeah, yes, of course. So everywhere you have to put the value unit as per unit p dot u. Okay, because we are representing everything with respect to the with respect to per unit values we are describing.
So
Yeah.
in this one, you are writing V21 as 1.00372. How come, sir? It's 1.0496 only, no, sir. 489 plus 0.0376 only, no, sir.
Okay, this one have you? Okay, this one have you changed with respect to your rectangular form?
Yes, sir. If we change it, it will be 1.0489 plus 0.03768, sir.
Okay. So just a minute. So just a minute, I'll be taking my calcium.
Sir, if we found V2 acceleration in the next voltage regulation calculation, we should use the acceleration voltage only, yes, sir.
Over the process of iteration, you're asking, right?
Yes, sir.
Yeah, you
If
have
we
to
found
consider your acceleration voltage only.
in that case, so also V2 acceleration is equal to V2 only, sir. So the rectangular
Because
form is 1.048 something only, sir, plus 0.0376 J.
just a minute, I'll be seeing. So you are getting around 1.048, right?
Yes, sir. 1.048
Okay.
489, sir.
Okay, you just change it. So here I have made a mistake. While calculating also I have made it. So okay, just change the value. So you'll be getting around. So you'll be getting V3 dashes.
So what, sir?
You'll be getting the V3 one as what value you are getting current.
Sir, it's 1.076 at an angle of 2.072, sir.
So you can just tell me the
Rectangular form, sir.
rectangle form.
1.0754
754.
plus 0.0389 J, sir.
Okay, over here.
It's V3 one acceleration is equal to V3 one only, no, sir.
Yeah, both.
The
You just say the
polar
polar form. Polar form.
1.076
7.6.
at an angle of 2.072, sir. 0.72.
Okay, just take this. Okay.
So for the next iterations, we should use the acceleration voltage only, no, sir.
Acceleration, yeah, acceleration voltage only have to take. If they are over here, the acceleration is constant. That is, they have given to be one. Okay, but in
Okay, sir.
some cases, it just gets varied. Okay, it just gets
Okay, sir.
varies. So as per that, you have to always take the stick on with the acceleration value. Okay. So coming to over here V4, also this value changes. Okay.
So, but in previous formula, we would have used not the acceleration, but the normal V2 one, sir, for
Where you
finding
are,
V3. For the previous one, sir. Initially, you took one Gauss Siedel problem, no, sir, with the PQ bus alone.
just a minute. That is the Gauss Seidel problem one you are asking, right?
Yes, sir. So in that one, you won't be using the V2 one acceleration, sir. You directly put up the V2 one. Normally, we got one answer, no, sir. You substituted
Okay.
that one in V3 one, sir.
No man, we'll be taking acceleration quantity only.
Okay, sir. Then I might have substituted it wrongly. Maybe. Okay, sir.
You have to stick on with the acceleration quantity only.
Okay, sir.
So KV for what you're getting, you just tell me the polar form directly.
So it's 1.098
Okay. Turn angle.
at an angle 3.289, sir.
Okay. Okay. So this is with the problem, and next we will be moving to the next model. That is the model that we had already discussed. That is what happens if your Q2 limit is violating. Okay, so in this problem, your Q2 limit is not in a violation, but the next problem is this thing, the same problem, but over here the Q2 limit we are changing. Entirely the same problem, but over here the Q2 limit is changing from 0.2 to 1.0. Okay, so in the previous case, whatever we had done, it's starting from the admittance matrix formation, calculation of your Q2, everything will be up to that, it will be the same step. Okay, but after that, how we will be approaching is that we'll be seeing. Okay, so the same problem we are repeating, but over here the slight variation is that they have varying your Q limit. Your Q limit is varied. So in last problem, I think they have given around 0.1 to 1.0 they have given, and now they are giving zero point 0.2 to 1.0 they are giving. Okay, and okay, so the Y bus what we have formed in the previous case, you can consider the same Y bus. After that, we'll be moving towards your first iteration. So in the first iteration, your slack bus is your first bus. The slack bus is the first bus, so it will be V1. So it will be 1.06 at an angle 0.0. So J 0.0 per unit. Okay, so this is with your slack bus. So after this, we have calculated the value of your QP using the formula. So using this formula, we have calculated your QP.
Sir, for tomorrow's exam, we will get only one iteration, sir.
Yeah, one single iteration only will be getting now.
Up to this problem, sir.
Yeah, up to this problem. Yes, I'll be just telling you how to approach this problem. We'll be saying, and next we'll be discussing about tomorrow's exam and any other doubts, sir. We'll be discussing about that. Okay. So, as per this equation, we have solved the equation, and we have got your Q value as to be 0.1456. Okay, 0.1456 is the value, and the range of the QP, what they have given is that is the Q limit. What they have given is 0.2 less than equal to QP less than equal to 0.1. So this is the limit they have given. But over here, that is your QP varies from 0.2 to that is 1 to 1. It varies. Okay, but over here it is very clear that this 0.1456 is still less than your 0.2. Okay, it is still less than your 0.2, so this doesn't fit in this range. But the most minimum value, okay, the most minimum value which is nearer to this calculated value is this 0.2. Okay, it's this 0.2. So with respect to this, you have to consider your QP calculated, that is QP that is Q2 Q2 calculated to be 0.2. Okay, so this simple step alone, you just have it in your mind, and after this you have to do the entire problem again. Okay, so this is a slight variation in this model. Using this Q2 value, you have to calculate the voltage equation for your second bus, then followed by the other two PQ bus you have to follow on. So if you have they're giving here, if you are getting the Q2 value, if it is greater than 1.1456 like that, it's coming means, then you have to consider this upper limit. You have to go towards your upper limit. Then your Q2 calculated will be equal to 1 per unit. Okay, if it is moving above this above the upper limit, you have to consider your upper limit. Okay, so after this other steps are the similar, so you just straight out by yourself. Okay, and if you are having still clarification over here, you just refer, you can get through your notes also. So the same problem is given in the notes also. Okay, so okay, with this I think we can finish about the problems, and I have given assignments, right? So whether you're having any query in the assignments. So assignments is simple only. Still, I found that still many of them didn't complete the assignment. So don't forget, today is the last date. Okay, within today 12 o'clock, you just try to turn over. Okay, so today is the last date for your assignment one. So don't forget about it. And whether you're having any kind of doubts in your assignment one or any other things, you can just
Sir,
ask.
sir, regarding the matrix, bus matrix, we have only admittance matrix, no, sir. No,
Impedance also, impedance matrix also there.
sir, but you did not teach that Z
Yeah,
bus.
that Z bus is not coming under first unit. Okay, so you just stick on to syllabus. So in the notes I might have given Z bus building algorithm. Don't get
That is
confused
not
with
there,
that.
no, sir. Only
It's
Y
not
bus
that.
is
Yeah, only Y bus is there.
per unit analysis, Y bus and this problem, sir.
Yes, man. Yes, man. You just stick on clearly with your syllabus. Okay, wait. I'll be just presenting you the syllabus. So here's the syllabus. So don't get confused. The Z bus building algorithm is in the third unit. Okay, so here you can see it is in the third unit. So don't get confused with that. And over here we have completed up to this one. Okay, we have completed up to Q limit check for voltage control buses. We have completed. So up to this, it is entirely there for your uh, unit CAT exam one. Okay, and over here the in the first unit you have to concentrate over your Y bus, and there are some theory part. Okay, some theory part with the initial uh, lectures in the unit one. You can get through it. It's in the PPT as well as in the end of the notes also. It's there. Okay, so in most cases this the theory part will be corresponding to the transmission and distribution what you have already studied. That is with respect to your structure of your power system. Okay, power system network, such kind of theory will be there. So apart from the theory, you just see the problems. Okay, problems are very important. Okay, I hope again for you this will be open book test, right? Cat one is a open book test, right?
Yes, sir.
Okay, okay. So it will be easy for you because most of the questions I hope it will be coming around from your notes assignment, and some might be deviating. It will be getting into the books. Okay, so even if you are not able to get it, you just try it out on yourself and try to arrive at some answers. Okay, try it out on yourself, so you'll be getting some clear idea. And so over here we have covered most of the theory parts. Okay, so we have seen the importance of power flow classification. Okay, any other doubts is there? You can just ask me. So I'll be there. So I have also given the ebooks, right? So the Google Classroom ebooks are present. You can just see through the ebooks also if any question is deviating from some other resources. Okay, so mostly it will be in these four books. Okay, so mainly the question will be coming from your notes only. From this notes only, it will be coming out. Uh, Even for both unit 1 and unit 2, it will be coming out from your notes. And for theory part, you can see the last at the end of it, the theory part will be there, end of the notes. You can see through it, and also the it is also given in the PPT. You can also refer to the PPT. Okay, you just see through it. Okay, so the notes it will be given the theory part, So any other query you can just ask me. So it will be easy only. Tomorrow exam will be more or less it will be easy only. So you just stick on towards your methodology. Okay, how you are forming your Weber's, how you are formulating the Gauss Siedel methodology. Okay, so such kind of things you just stick on. So any other queries you can just ask me.
No doubt, sir.
Nothing,
Okay,
sir.
other student. Okay, other students. So those who
No, sir,
didn't
no
submit
doubt,
your
sir.
okay assignment, you just try to complete out, man, because many didn't submit turn out, and try to turn it out within today, so that it will be useful for you in tomorrow's exam. Also, it will be useful for you. Okay. Okay. I'll be there for a few minutes. If anybody need to ask out, you can just ask. So otherwise, you can just move on. And all the best for tomorrow's exam. So do it well, and try to present. So presentation is very much important. Try to present in a very good manner. Whether the answer is right or wrong, don't worry. But your presentation plays a very important role. So try to present in a very good manner, so you can fetch high marks. Okay. Okay. I'll be there. You can just ask. Okay. So and Karan, you're there.
Ah, yes, sir. Yes.
Karan, actually tomorrow morning for your exam, right? Morning time.
Sir, two exams, sir.
Oh, per day two exam. Ah.
Ah, yes.
Sir, tomorrow
Okay.
morning 10 o'clock, sir. 10 to 11, sir.
10 to
11:30.
11.
Before
Yes, sir.
11:30, we have to
10 to
submit our
11,
exam.
sir.
10 to
10 to
11
11
morning.
and 2 to 3.
Okay. So okay. So within that you have to write and you have to scan it out and upload, right?
Yes,
Sir,
sir.
Sir, extra half an hour is there
A
to submit,
half an
sir,
hour
till
will be
11:30.
given, sir. 11 to 11:30. Within 11 to 11:30, all of them should scan and upload it in Google Classroom.
Okay. Okay. Okay, then okay, I'll be scheduling at 10 o'clock. Okay, I'll be scheduling the exam at 10 o'clock. So ours is at the morning,
Sir,
right?
but 15 minutes of the start of the exam, question paper will be posted, sir. Generally,
Okay,
at least
okay, man.
15 to 10 minutes before.
Okay, man. Before 15 minutes, I will be scheduling. No problem with me. So tomorrow our exam at the morning, right?
Yes, sir. Yes,
yes,
sir.
sir.
So then within 3 days, for you the cat one will be over, right?
No, sir.
Yes, sir.
For each,
Monday
Each
it will be
exam,
completed,
1
sir.
day break will be given, sir.
Okay.
Sir, our exams will complete at 23rd, sir.
23rd,
Monday. 23rd
Monday.
afternoon itself, all the exams will be completed, sir.
Oh, okay, man. Okay, okay. So after this, whether they have told anything about placement regarding anything
No, sir.
about okay, okay, man. Okay, thank you. We'll be seeing. Okay.
thank you, sir.